we'll be looking at a lesson on the order of operations. Let's first make sure you have a copy of the note sheet here. I will put a link in the description if you'd like to download one to print and follow along. That would be great. We'll begin with the order of operations, which you may have learned with the acronym PIMDOS. Um, I write my PIMDOS a little different than others might have, simply because the M and the D step go together. But let's put what each of these letters stand for. So P is for parentheses, and E is for exponents. Now the M and the D go together because we actually multiply or divide in order from left to right. And then our final one, that add and subtract, I put together again because we add or subtract in order from left to right. And you may have learned the phrase, please excuse my dear Aunt Sally, to help you remember the order of those letters or the order of the operations here. We're going to look at a few examples here because I just feel like the examples make the order of operations come alive. So let's look at the first example here. I start on the left and I'm looking for parentheses first. You might even want to write your PIMDOS over here and use it like a checklist. I don't see any parentheses, so I'll mark that one off. I don't see any exponents, so I get to mark that one off. Starting on the left, I come to a multiply here first. You may even want to highlight it, just the multiply part. Then you can rewrite the rest of the problem and just calculate the 14 times 3. Feel free to use a calculator for that if you want to. All right, we haven't finished the multiply or divide step, so we'll start here and we come to this division. Again, I'm going to highlight it because the rest of the problem is going to stay the same. 42 divided by 6 would give me 7. And now I'm done with this step. Now we add or subtract. 15 minus 7 is 8. Okay, I think the highlighter will help you to focus your eye on the part of the problem that you're actually finding a value for. This one's a little tricky because of the fraction here. So we're going to do the top and follow the order of operations. We're going to do the bottom, follow the order of operations, and then we'll take care of the fraction together. So on the top, we're going to take care of that multiply on the left first. So we're doing 2 times 7, which would be 14. I'm rewriting the rest of the problem. Okay. The more comfortable you get with the order of operations, the more you can do more than one step at a time. But if you're just beginning, I definitely recommend that you do one step at a time. I'm still on the top and I have not finished the multiply or divide step. By the way, we were able to skip the parentheses and exponent step because we didn't have any of those. So again, I'm writing the rest of the problem, keeping that all the same, except for the part I highlighted. 5 times 3 is 15. Okay, still working on the top. Now I'm going to do my add or subtract, which gives me 29. And again, I'm leaving the rest of the problem the same. Now I'm ready to look at the bottom to do that subtraction. 30 minus 29 gives me 1. 29 divided by 1 is 29. So that's my final answer there for that problem. Okay, notice how I did all of the top, then I did the bottom, and then I did the division of the 2. Let's look at number 3 here. We finally get some exponents to work with. Again, I'm skipping the parentheses step because I don't have one. I take care of my exponents in order from left to right. So I'm going to calculate that 3 to the second first, but remember, I am going to rewrite the rest of the problem. 3 to the second. Now remember that means that we write the 3 2 times and we multiply. Okay. 3 to the second does not mean 3 times 2. It means 3 times 3. And so 3 times 3 is 9. Okay. Still not finished with the exponent step. So I'm going to highlight the next exponent we need to take care of. Rewriting the rest of the problem. Remember, 6 to the second does not mean 6 times 2. It means to write the 6 2 times and multiply. So 6 times 6 gives me 36. And now I'm finished with my exponent step. We're ready to move on to the multiplier divide. So from the left, again, I come to this multiply step first. So I'm going to rewrite the rest of the problem. And then I'll do the 9 times 10, which is 90. Still not finished with the multiplier divide step, but I come to this division here. So 36 divided by 12, leaving the rest of the problem the same. 36 divided by 12 is 3. And now I'm ready to do my add or subtract. Of course, it's a subtract there, and that gives me 87. Okay. I am being very deliberate to do only one step at a time. So I don't want to confuse you. I don't want to move too fast. Okay. But the more comfortable you get with these, the more you can do more than one step at a time. All right. Look at number 4. Finally, we have a parentheses to work with. So I'm going to highlight it. I'm going to rewrite the rest of the problem. By the way, if you missed it, the note sheet here is in the description if you need it. And now we do the parentheses, which is 2 times 3, which is 6. Okay. Finished our parentheses step because the parentheses that I have doesn't have an operation inside of it. Now it just means a multiply there. So we're going to go to exponent. So I'm going to take care of my 3 to the second. I'm going to rewrite the rest of the problem. And remember, 3 to the second means to write the 3 2 times and multiply. So 3 times 3 is 9. We finished our parentheses step. We finished our exponent step. Now we're going to multiply or divide in order from left to right. So notice if I start on the left and I come to this division sign first. So it is taken care of first, even though it's multiply or divide in order from left to right. So 16 divided by 4 is 4. And then I have the rest of the problem is staying the same. Now, again, from the left, we come to this multiply step part. And so 4 times 9 is 36. Again, leaving the rest of the problem the same. One more multiply here because see now that number written in front of that parentheses means to multiply it. And so 6 times 6 is 36. And now I can do subtraction, which is 0. Take your time with the order of operations. You'll notice how I wrote a lot of steps out, okay? And I use your highlighter to focus your eye on the parts of this problem that you're going to be evaluating next. Now let's continue this lesson by talking a little bit about variables. Variables are symbols that are used to represent numbers. A lot of people tell me I was fine with math until they started putting the letters in there, okay? Now, a lot of our variables are the lowercase letters, and we use X and Y quite a bit, but it doesn't have to be X and Y, okay? Now, then when we use the phrase evaluate an expression, what we mean is to replace the variables with a value and simplify. So let's look at these two examples here. We are told that X is 3 and Y is -5 and Z is -2. And we want to evaluate these expressions. So what that means is we're going to replace the X with a 3. And we're going to replace the Z with a -2. And then we're going to simplify. Now, when we add in order from left to right. So I'm going to do these two first. 1 plus -2 would give me +1. And then 1 plus -5 would give me -4. And you can use your calculator on those to help you, definitely. Let's look at number 6 then. We're going to, again, evaluate the expression. So we have a little absolute value going on there. We have -y. So if y is -5, then we have -5. -5, which would be +5. Then we have -x. Well, if x is 3, then that would be -3. Okay. Now, the absolute value symbols here we'll treat like a grouping symbol. So we're going to simplify inside of it first, and then we'll deal with the absolute value. So negative 20 plus 5 would give me negative 15. Feel free to use your calculator on that. And then negative 15 plus negative 3 would give me negative 18. And now we deal with the absolute value of negative 18. Well, absolute values just ask us what is the distance negative 18 is from 0? Or some people like to remember a little shortcut that whatever's inside the absolute value has to become positive when it comes out. So that absolute value of negative 18 becomes positive 18. All right, let's look at number 7. When you see a number in front of a variable, that means to multiply. So this means 6 times x. Now, if x is 3, then we'll rewrite this as 6 times 3. Then we have 9y. Well, if y is negative 5, then that means 9 times negative 5 minus 2. Now remember, order of operations tells us we have to do the multiplication before we do the addition or subtraction. So I'm going to do this part first. 6 times 3 would give me 18. Rewrite the rest of the problem. Then we do the next multiplication. So 9 times negative 5 gives me negative 45. Now we're ready to add or subtract in order from left to right. Again, feel free to use your calculator to help you. I have linked the Desmos calculator below in the description. So 18 plus negative 45 would give me negative 27. And negative 27 minus 2 would give me negative 29. Again, feel free to use your calculator on that. That free online graphing calculator from Desmos is a game changer. I hope that whatever math class you are taking, you definitely have that bookmarked. Okay, let's look at number 8 then. We have XYZ on top. Now remember, anytime they're written beside each other with no symbol, that means multiply. And then on bottom, we have Z minus Y. So on top, let's put them together as a multiply. 3 times 5, times negative 5 times negative 2. And on the bottom, Z minus Y, so negative 2 minus negative 5. Watch the signs here, negative 2 minus negative 5. I put it in parentheses just to make it stick out. All right, let's start on the top with multiplying. 3 times negative 5 would give me negative 15. Leave the rest of the problem exactly as it is. Now, still working on the top. Negative 15 times negative 2 would give me 30. And then on the bottom, I want you to be real careful. You can use your calculator to do that negative 2 minus negative 5. I'm going to use a little shortcut that says we change the subtraction to an addition sign by changing the sign of the next number. And so that ends up being negative 2 plus positive 5 on the bottom, which is 3. And then finally, we can do the division here. 30 divided by 3 would give me 10. So 10 would be my answer there. All right, now we're moving pretty quickly through these. We have talked about the order of operations. We evaluated an expression. Now we want to talk about like terms. Now, like terms are terms that contain the same variable, and those variables have the same power. For instance, 2x and 3x would be like terms, but 2x and 3x squared would not be like terms. See how they have the same variable, but not the same exponent. Let's look at another one. Negative 3xy would be a like term with 4xy. Okay, but negative 3xy to the second would not be a like term with 4x to the second y. You see how they have the same variables, but the exponents are not the same for the same variable. Okay, so got to have same variable, same exponent in order to have a like term. Why is that a big deal? Because we want to combine and simplify expressions with their like terms. So when I look at an expression like number 9 here, where I want to simplify the expression by combining like terms, the first thing I want to do, and I encourage you to do this because it makes it a little simpler for yourself, is I'm going to change these subtractions to addition, and I can only do that if I change the sign of the next number. Change this subtraction to addition and change the sign of the next number. One more. It helps when you start combining them. Okay. So let's begin with the ones that have X's. Okay. That's going to be the 7x. I'm going to draw a square around it, and the negative 10x. When I combine those, 7x plus negative 10x, I want to add the numbers that are in front, but not change the variable in the exponent. So 7 plus negative 10 would give me negative 3x. Notice I didn't put an exponent on this. I just had a negative 3x. So that's part of my answer. Next, let's do the terms that have just a y with them. And this one I will put a square around again. So in this case, we're taking negative 3y and we're combining it with 8y. Again, we're going to add the numbers in front. Negative 3 plus 8 gives me 5y, not changing the exponent there at all. Okay. And then finally, we'll do the ones that don't have a variable with them. And by the way, it looks like I forgot one. Got to change that to an addition by changing the sign of the next number. So we call these the constants because they don't have any variables with them. So we're adding negative 5 plus negative 8. And negative 5 plus negative 8 gives me negative 13. So I'll just put that as a minus 13. So my answer here are the three terms that I get when I combine the like terms. Notice I cannot combine these any further. They do not have the same variable or the same exponent. Okay, let's look at number 10. Again, I'm going to go through and change my subtractions to addition and change the sign of the next number. Change my subtractions to addition, change the sign of the next number. And let's go ahead and combine the terms with xy. So here's one that has an xy, and here's one that has an xy. So we're combining 4xy with 7xy. Remember, we're adding the numbers in front, so that gives me 11xy. That's part of my answer. Okay. Now look at the next two. This is a negative 4xz. This is a negative 11yz. Not the same variables. We cannot combine them. So what do we do with them? I'm glad you asked. We put them in the answer. So we put the minus 4xz from this one, and I put the minus 11yz from this one. And that's my answer. I cannot simplify that any further. Okay. I know a lot of students who mark them out as they use them, as they combine them, and that's a great thing to do. Okay. Now let's put the two steps together. We're going to take this expression and simplify it, meaning we're going to combine the like terms, and then we're going to evaluate using these values for x, y, and z. So let's start by changing our subtractions to addition by changing the sign of the next number. Later on, the more you get comfortable with this, the less you'll have to do that because your mind will go ahead and change it for you. But as a good rule of thumb, as you're starting out and practicing it, I definitely encourage you to do that. So let's do the x's first. So here's 7x, and then I've got negative x. So 7x plus negative x would give me 6x, and I'll put that in part of my answer. Let's do the y's. So I've got negative y and negative y. We'll add those together. Negative y and negative y would give me, oh, that's tricky because I don't see any numbers there. Well, friends, if you don't have a number in front of the variable, there's understood to have a 1 there. Okay, so this is negative 1y plus negative 1y, which would give me negative 2y. Okay, so we'll put that there. And then one more, we'll do negative z plus z negative z plus z. Remember, understood ones there. Negative 1z plus positive 1z is 0. So that's why we're not going to have a z show up in my final answer at all. So let's take our simplified expression now, and we'll plug in the values we know. So in place of x, I'm going to substitute a 2. So that's 6 times 2 now, minus 2 times negative 4 in place of the y. Now remember, order of operations tells us we're going to multiply first. So I'm highlighting that. 6 times 2 is 12, minus 2 times negative 4. Rewrite the rest of the problem. Now, not done with that multiply step, so we're going to do this 2 times negative 4 part. So 2 times negative 4 gives me negative 8. Watch that. That is minus negative 8. Okay, so you remember that tool we used by changing the subtraction to an addition, by changing the sign of the next number? Well, we're going to use it again here. 12 plus 8 gives me 20. So 20 is the value when I evaluate. Okay. All right, one more. Let's see if we can combine these like terms. I'm going to change my subtractions to additions by changing the sign of the next number. Ta-da, just like that. Let's do the x's first. So we'll combine 5x and 2x. 5x plus 2x will give me 7x. That will be part of my answer. Okay, then let's do the negative 2xy's. So we'll do the xy terms. So we got a negative 2xy and a 3xy. So negative 2xy and a 3xy. That'll give me 1xy. So we'll put that as part of our answer. You can write the 1 or you cannot. It doesn't matter. Going to mean the same thing either way. Then let's do the y terms. So we got 4y and negative 3y. 4y, negative 3y. That'll give me 1y. Again, you can write the 1 or not. And friends, it looks like we just have one more left. So that negative z is going to be added on to our answer. Okay. So now we take our simplified expression, 7x plus xy plus y minus z. And let's plug in our values. Okay, so in place of x, we're putting 2. So that's 7 times 2. Plus xy would be 2 times negative 4. Y would be negative 4. And z would be 5. Okay, order of operations. We've got to do that multiply first. So 7 times 2 gives me 14. Rewriting the rest of the problem. Then we do the next multiply, which is 2 times negative 4. 2 times negative 4 gives me negative 8. Okay. And now we're going to add or subtract from left to right. So we'll do 4 plus negative 8. That'll give me positive 6. Then we'll do 6 plus negative 4, which will give me 2. And then 2 minus 5, that'll give me negative 3. And again, use your calculator there if that helps you. Friends, we've covered a lot. We've covered the order of operation. We've simplified expressions. We've combined like terms. We've evaluated expression. There's a lot of details here. Make sure that you go back through, rework some of the examples that I have here so that you build some confidence with these concepts. Thanks so much. Have a great day.